Hi everybody, Dr. Gray here. Today we are working on waves target 3. We will be measuring and making waves today. And this will be all part of our learning target, understanding the relationship between wavelength, frequency, amplitude, wave velocity, and energy. So in our previous lesson, we looked at the definition for wavelength, and we said that the wavelength of a wave is the length of one wave, and it's measured from a point on one wave to the same point on the next wave. And so we can look at this a couple of different ways. We can measure wavelength on a transverse wave from crest to crest. We could measure it from trough to trough. Likewise, we could measure it between any two consecutive points. And so we could measure from where the wave starts at rest, so right here, and where the wave is at rest again, where the wave looks identical. So the next time we are where the wave looks identical, we would be at this location because that's where we are beginning our upward climb into our crest. So we have one wave outlined by the red line here, and then the next wave begins at this blue one. And so if we wanted to measure between any two consecutive points using that point of rest, we could measure from there to there. And what we'll find is that the distance from those 2 points of rest will be identical as if what they were if we were measuring from crest to crest or from trough to trough. Those are all considered consecutive points. If we were working with longitudinal waves instead of transverse waves, we don't have any crests or troughs, but the rule of measuring between any two consecutive points is still there. And so we could measure from the beginning of this rarefaction to the beginning of the next rarefaction. We could measure from the beginning of this compression to the beginning of this compression. Likewise, if we wanted to, we could measure from the middle of this compression to the same middle of the next compression. And just as we saw on the transverse waves, each of those distances should be identical. So let's give it a try. If we start out with our transverse wave, first we want to notice that our measuring unit here is that each block measures 1 meter by 1 meter. And whenever we make measurements, we have to make sure we record the quantity, how much, and the unit. Are we measuring this distance in meters or centimeters or inches or feet? Those are our units. So you have to include both the quantity and the unit. And so let's look at this wavelength. Let's start by measuring from crest to crest. And so our first crest is here, and our second crest is here, or thereabouts. And if we measure how many blocks there are between those 2 points, what we find is that we have 12 blocks, or maybe 12 and a half blocks between those 2 blue marks. And so if one block is 1 meter wide, that would mean that our wavelength would be 12 meters. Now, if we wanted to measure amplitude, we want to remember that we measure amplitude from the rest line to the crest. And so just as before, we're going to measure from here to here. We're going to count how many blocks are there between those 2 red lines. And so if you take a second to count them, what you'll find is that there are 7 blocks. Each block is 1 meter tall, and so there are 7 meters for that amplitude. If we're measuring the wavelength for a longitudinal wave, the process is quite similar. We start and we measure between any 2 consecutive points, so let's pick those points. In this case, I'm going to measure from rarefaction to rarefaction, from the beginning of this rarefaction to where the wave looks the same the next time. And so the next time the wave looks the same, we're over here. And so now we have to measure the distance between those 2 points. just as before, if we count the number of blocks between those two red arrows, we find that we have 11.5 blocks. And since each block measures 1 meter by 1 meter, our wavelength is 11.5 meters. Now, what if we want to draw a wave? Well, drawing waves is a little more challenging than just measuring the wave properties. But there are some tricks to that to make your life a little easier. And so let me show you both of those. In this problem, we want to draw a transverse wave. So we want a wave that looks like this. And we want the wavelength to be 8 meters. Remember, that means that we want the distance between two consecutive points to be 8 meters apart. And since each block measures 1 meter by 1 meter, what that means is we want the consecutive points to be 8 blocks apart. And so, to help me out with this, I'm going to just make some marks on my grid paper here to help make this a little easier for me. Here's my starting point. I'm going to start my wave there, and I know that my wavelength needs to be 8 meters. So I have to have a crest, come back down through the point of rest, and move back, draw the trough, and come back up to the point of rest in a space of 8 blocks. So let's just mark out those 8 blocks. So we have 1, 2, 3, 4, 5, 6, 7, 8. Always double check. And so there's my first 8 blocks, and then I need another 8 blocks. So 1, 2, 3, 4, 5, 6, 7, 8. So we're there. 1, 2, 3, 4, 5, 6, 7, 8. So we're there. And the reason I drew out 3 separate sections is because in order to draw a wave that allows you to measure wavelength or amplitude or frequency, you have to have at least 2 waves in that wave train. And so I drew enough space here to put 3 waves in our wave train. Now, this problem only asks us to or only specifies the wavelength. It doesn't tell us anything about amplitude. And so if it doesn't tell you anything about amplitude, you be the judge. What's important to remember now is that the amplitude has to stay constant. You can't start out with an amplitude of 1 and then change to an amplitude of 5 and then go back to an amplitude of 1. We want the amplitude to be the same throughout. We also need to remember that the amplitude is the distance between that point of rest and the crest, and it's the same distance between the point of rest and the trough. And so that means that if we're considering the little hills to the crest, the hills have to be as high as the troughs are deep. And so we want to be careful about that. So to help myself be careful about that, I'm going to draw in some guidelines for that amplitude. And so I'm going to put my amplitude guidelines there. It's going to give me an amplitude of 4, and so I need my amplitude down here, or my guidelines for my amplitude down there to be 4 as well. Now, the last thing that we need is we need to know where our wave, as we're drawing it, is going to pass through that point of rest. And in all cases, the point of rest is halfway between the 2 endpoints. And so I'm going to draw myself a little mark here. I'll do it in red to make it obvious. I'm going to need a point of, I'm going to pass through the center there. I'm going to pass through the center there. And I'm going to pass through the center there. And now that I've got some guidelines, the drawing is pretty easy. And so we start at our point of rest. We go up through the rest, down to the trough, and back up to rest, and then repeat until we have our complete wave train. In this next example, you're being asked to draw a transverse wave with an amplitude of 5 meters. So in this one, it doesn't matter what our wavelength is, but our amplitude has to be 5 meters. And just like before, each block still measures 1 meter by 1 meter. And so, just like we did before, we're going to put ourselves some guidelines in. We have our point of rest. We need to know that our amplitude is going to be needs to have a value of 5. And so I put in my guidelines 5 blocks above and 5 blocks below that point of rest. And it doesn't matter what my wavelength is, and so I'm just going to give myself some marks. If I start here, then say 5 later, we'll make it 5 by 5. 5 later is going to go through the point of rest, come back to rest. Then another 5 here, and another 5 here, and another 5 here. So equal spacing to make it a little easier on me. Now, in the previous example, the crests and the troughs of my waves were nice and smooth. They looked very sine wave-like. And sometimes that's really difficult to draw. And I know that there are some of you out there that are thinking, I am never going to be able to make a wave that looks like that. But this isn't an art class, and so I don't care if your wave looks like a perfect sine wave or it doesn't. What I care about is if I measure your wavelength or I measure your amplitude, am I going to get the correct value? And so here's a little trick that I'm going to offer you. The tops of your waves don't have to be curved. They could be pointy, and that'll make it a little easier if we just do kind of a zigzag line. So our amplitude needs to be 5 meters, so we start here, up to the crest, to the rest, down to the trough, up to the rest, up to the crest, down to the rest, down to the trough, up to the rest. And so in that way, if we were to double check after the fact, well, how high is our amplitude? Our amplitude is still 5 meters. And if we were to double check our wavelength, well, now our wavelength is going to be about 10 meters. And anywhere we check, it's about 10 meters. This picture still represents a wave with the correct amplitude and a consistent wavelength. Now in this next example, we're going to add both. We're going to have to draw a wave with a particular wavelength and a particular amplitude. And so it's really not too different from the ones we've done before, except now we don't get to choose either the wavelength or the amplitude. You have to go with what the problem asks for. And so our wavelength is 8 meters. And so we're going to put in our guidelines. We're starting here, starting there, 8 spaces away. Let's see, we're going to need halfway point, or 4 spaces away will be our halfway point where our wave comes back through the rest. And so we got 8 there to rest, 8 there to rest, and 8 there. So that'll give me enough room to do 1, 2, 3 waves. And the amplitude needs to be 5 meters. So I got to go up to here, and I go all the way down to there. So there's my guidelines. And this time we'll do a pointy wave. Up, down, up, down, up, down, up. And so now our amplitude, if we measure it, is 5 meters. And our wavelength, if we measure from here to here, is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. A little bit sloppy. Hard to do this on an iPad with a stylus, but you get my point. Now let's look at longitudinal waves. In this problem, we want to draw a longitudinal wave with a wavelength of 5 meters. And so remember, longitudinal waves have lines that represent the compression, and then they have lines that represent the rarefaction. In order to have a wavelength of 5 meters, the starting point of each compression needs to be 5 meters apart. And so if we're starting here, well, I draw in my first compression. 1, 2, 3, so there's my little compression. 5 blocks from where we started, the next compression has to start. And so I'm going to go ahead and draw in both of those compressions. So 1, 2, 3, 4, 5. So here's the starting point of my next compression. And so I draw in my next compression. And then 1, 2, 3, 4, 5 later, I'm going to draw in my next compression. And so if you'll double check, from here to here is 5 blocks. From here to here is 5 blocks. And so I have set my wavelength at 5 meters. But I don't have all of the parts that I need for this longitudinal wave. I've only drawn in the compressions so far. And so now I have to go back in and draw in the rarefactions. Easy peasy, lemon squeezy. Now we have drawn a longitudinal wave with a wavelength of 5 meters. So the last thing that we want to be able to do is we want to be able to measure frequency. And this is a little bit more challenging. The way to do this is we have to think about what a single wave looks like so that we can count the number of waves in that wave train. So if we're talking about a transverse wave, remember that a transverse wave has to have a crest, has to have a trough, and has to start and end at rest. And so if you go over into our wave train over here, we're looking for how many waves? Well, we have our first wave here, and we have our second wave here, and so there are 2 waves. Another way you can look at this is, well, there are 2 crests, and there are 2 troughs, and so this wave train contains 2 waves. So now let's go about measuring frequency. Frequency is a measure of how often something happens. If I were to ask you, how frequently do you go to the Buckfield Mall? If you said 10 times, you haven't given me often-ness. You've told me how many times you have been there. In order to report frequency, you have to tell me how many times you've been there in some measured time frame, right? You could tell me I've been there 10 times today. I have been there 10 times this week. I have been there 10 times in my life. We've had 10 times, 10 trips, and we've measured those number of trips relative to some time unit. And so if we're doing frequency of waves, we have to do the same thing. Frequency is always measured as the number of waves that occur in 1 second. And so for that reason, frequency of waves is measured in hertz. Hertz would be the unit of waves, where 1 hertz is equal to 1 wave per second. So if we had 50 waves in 1 second, we would have a frequency of 50 hertz. And so if I want you to measure the frequency of a wave, the first thing you have to figure out is, well, how many events have we had? How many waves do we see? And so we look at our wave train and we figure out how many waves are there. Well, we have 1 there, 2, 3, 4, 5 waves. 5 waves. And then down here, it tells us it takes 1 second for the waves to travel the distance shown. Well, the time period then is 1 second. Well, that means that our frequency is 5 waves per second, or 5 hertz. That's it for today. We'll see you in class.